Hello, today we'll be looking at rates of reaction topic. This comes up in paper 2. It's quite an important topic because there's quite a lot of questions linked to it, and it also has required practicals. So let's look at the factors that speed up the rate of reaction by referring to collision theory. Surface area is, if you're looking at rate of reaction in surface area, the larger the surface area, I'm just going to call it SA, the more particles and more collisions. So if you go more successful collision, therefore you'll have a faster rate of reaction. So the larger surface area, the more particles they are colliding, the faster the rate of reaction will be. So an example can be if you had a cube sugar and then you grind it into a powder sugar, and what you realize that the powder sugar's got a larger surface area because it can interact, each of these particles can interact with the liquid that's going to be surrounding it. Equally, the higher the concentration, just going to shorten it to conc. So the higher the concentration, more particles, of reactant, more successful collisions, therefore faster rate of reaction. And again, if you was to look at this example, if you had like a 2 molar solution, then you got lots of particles in that solution compared to 0.5 molar. So you got a higher concentration, you have more particles. Temperature, the higher the temperature, I'm showing it to temp. The higher the temperature, particles gain more kinetic energy, which then means they're moving much faster and colliding more. Hence, therefore, faster rate of reaction. So the higher the temperature, the faster the particles are moving. So the more bombarding into each other, resulting in the rate of reaction to be the faster. So if you then have a reaction at 35 degrees compared to 20 degrees, the rate of reaction will take less time in order for that reaction to complete because the particles have more energy to move. A catalyst, it speeds up the rate of reaction. And it does that by taking an alternative route, or by reducing the activation energy. Activation energy is the minimum amount of energy needed for a reaction to take place, and it can be reused. So as a catalyst, it's just speeding up the rate of reaction. It doesn't actually take part and it can be reused. And it does so by two means. Pressure only applies to gases. So the higher the pressure, less particles, space, therefore more collision and faster rate of reaction. So what that means is if you're filling up a balloon and you have lots of air in the balloon, the particles got less space to move around, hence those particles in the balloon will have to collide with each other, causing the rate of reaction to be faster. So each of these boxes link to rate of reaction. These are all of the different factors you need to be able to explain in the exam. They're quite straightforward if you understand the concept. And you will see that you will do a required practical for most of these in the class. In terms of surface area, you might be given solid marble chips or a powdered marble chips with hydrochloric acid, and you time how long it takes for the reaction to take place. Concentration, you might have a range of molarities, 2 molar, 1, 0.5, 0.25, and again you may react with marble chips and see how quicker that rate of reaction takes place with a higher concentration. Temperature seems to do sodium thiosulfate experiment where you heat the sodium thiosulfate with HCl and you put it on a cross and you time how long it takes the cross to disappear. We don't tend to do pressure experiments as much in the class. And a catalyst, you can have a range of different catalysts and time how quickly the reaction takes place.